Hello, and thank you for tuning in to this video discussing Holt-Winter's forecasting method, also known as exponential smoothing with trend and seasonality. And this name already reveals why this forecasting technique can be useful when data exhibits trend and/or seasonality. And that's exactly the case in the data set we're looking at here. You see, I've already graphed it for you. Here we have a little over 2 years worth of data. In this case, we're having weekly data. And if you look at this graph right here, you notice a recurring pattern that indicates seasonality over the course of about 2 years. And you also see a little bit of a trend, a little bit of a positive trend to be specific. So in this instance, we are well advised to use Holt-Winter's forecasting method because it will adequately capture not only the level of demand, but also the seasonal variation as well as the trend over time. In this video, I want to show you how to actually implement this forecasting technique. Now, I'll be honest with you, it's a little bit more involving in terms of requiring us to go through a series of steps to actually calculate forecasts. But again, we're doing this here because it's very powerful and actually widely used in practice. So we're going to start out by taking a look at how we actually develop the forecast. So in Holt-Winters, what we basically do is we break down an actual demand observation into 3 components. And those 3 components are the base level, the trend component, and the seasonal factor. As we implement Holt-Winters, we first need to decompose actual demand observation, and that's our point of sales data. And ultimately, when we develop forecasts, we will recompose the demand expectation by summing up all 3 elements. That is the base level, trend, and seasonal component. It is called exponential smoothing with trend and seasonality because similar to the simple exponential smoothing method, we apply smoothing factors. The difference is here, as we break down demand into those 3 components, base level, trend, and seasonality, we will then apply a smoothing constant to each one of those components, which is why we have 3 smoothing factors, that is alpha, beta, and gamma. Let's go and actually implement this technique. First, we must start out by seeding the seasonal factors. The way we do this is we simply start out with the first period for which we have data, and we take the actual demand observation and subtract from it the average demand observation of the course of the first year. In our case, that is, of course, the first 52 weeks of data. So I take the average of the first 52 weeks, and I'll subtract that from the actual demand observation of the first period. Notice that I locked in the cell reference to the average of the first year worth of sales data. I'm doing that because I'm going to drag down this formula throughout the first year of data. So right now you see that the point of sale for week 1, for example, was 591. That is 147 units less than the average demand level over the course of the first year. So this is my seeding seasonal factor for week 1. And again, as I've just said, I'm going to drag down this formula for the remainder of year 1. Now notice, of course, that all the seasonal factors clearly sum up to 0, because again, I'm subtracting the average demand observation over the course of the first year from each individual demand observation. So this is my seeding estimate for the respective seasonal factors associated with every week. Now in the next step, we'll go to the last period of the first year worth of data, which is week 52. Now we're going to continue to seed our elements. We have already seeded seasonal factors. Now let's seed the baseline. This is actually quite simple. All I do is I take the actual point of sale observation, 768 in this case, and subtract from it the associated seasonal factor of 29.87. So I get a seeding estimate for the base level for week 52 of 738.13 units. And last but not least, we're going to see the trend factor. Now this is the easiest thing ever. We're simply going to seed it with 0. That's a common practice. So now we have beginning estimates for base levels, trend, and seasonality. And now what we're going to do for the remainder of the data set, we will continue to refine our estimate of base levels, trend, and seasonality. And the way we do this, remember it's called an exponentially weighted moving average. For each of these components, we're going to weight different ways of estimating these components. Let's start out by taking a look at the base level. For the base level, the smoothing constant is alpha. So I'll type here alpha. And now the first way of estimating the base level is to simply take the actual demand observation of the current period and subtract from it the most recent relevant seasonal factor element estimate. Now this sounds very complicated, but all it really means is that I subtract from the current actual demand observation the seasonal factor estimate from the year ago period. So since I'm in week 1 of year 2, then the year ago period that corresponds would be week 1 of year 1, which of course is period 1 in our case. And the associated seasonal factor was negative 147.13. This is one way again of estimating the current base level. Now I'll come up with another way of doing the same thing, and of course I'll again apply the weighting factor 1 minus alpha in this case. And the alternative way of estimating the current period base level would be simply take the prior period base level of 738.13 and add to that the prior period trend component, which was 0 in this case. Again, what I'm doing is I'm finding two different ways of estimating the current period base level, and I come up with a weighted average with alpha being the weighting factor. So right now, our base level would then be 767.93. Now I do a similar thing for the trend component. And for trends, our weighting factor is beta. Beta times, and again I'll find two different ways of estimating the trend. The first way would simply be to take the current period base level and subtract from it the prior period base level estimate. So the difference, or the increase or decrease in base levels, would be an indication of trends. Now, the alternative way of estimating a trend component would be weighted by 1 minus beta, and the alternative way of estimating the trend component would simply be to assume that the current period of trend is equal to the prior period trend, which in our case happened to be 0. So now we get a trend estimate of 2.98 for week 1 of year 2, or period 53. Now last but not least, we'll do the same thing for the seasonal factor. And here we'll use gamma as a weighting factor, or also called a smoothing constant. Now again, we find two different ways of estimating the seasonal factor. The first way would be to take the associated actual POS observations of 740 units, in this case, and subtract from it the associated base level estimate. In other words, I could argue that the difference between POS and base level, which is really what's accounted for by seasonality. And again, I add to that 1 minus gamma times again the alternative way of estimating the current period seasonal factor. And that would be simply to assume that seasonality is really the same value that it was in the year ago period. So that takes us back to week 1 of year 1. So again, I come up with a weighted average for seasonality. So now you see what I did was I broke down the POS observation into 3 distinct components, that is base levels, trend, and seasonal factors. These are estimates, and I come up with 2 different ways of estimating each one of these components and weight them by applying the respective weighting factors. Now the good news is that now that I have set up these formulas, I can simply copy them down throughout the remainder of the data set. So that takes us all the way through to period 109, or week 5 of year 3. And now I can finally come up with my actual forecast. So everything that I've done up until this point was really just to obtain these numbers right here. I need base level estimates, trend estimates, and I need a series of seasonal factors. Now my objective is to develop forecasts for the remainder of year 3. So I want to come up with forecasts for week 6 of year 3, or period 110, all the way through the end of year 3, meaning all the way through week 52 of year 3, which is period 156 in our data set. So let me show you how I'm going to do that. I'm going to start out by simply coming up with a 1-week forecast. So I am in week 5 of year 3, and I want to know or estimate what demand might be in week 6. The way I do this, I simply use the most recent base level estimate. And I'm going to lock in the cell reference because I'm going to rely on the most recent base level estimate for all subsequent forecasts. And I add to this most recent trend component estimate, which happened to be 9.7 in our case. Again, I'm going to lock in the cell reference because this is my most recent estimate for the trend component. So this is what I'm going to use for all subsequent forecasts. To that, I'm going to multiply this week's period minus last week's period, and I'm going to lock that. Since I'm in week 6 of year 3, the most recent relevant seasonal factor estimate will be that of week 6 of year 2. So I'll have to go back to the year ago period. So let me screw up a little bit to find week 6 of year 2. So you see the associated seasonal factor estimate was negative 148.5. So now you see this is my forecast for week 6 in year 3. So this is an actual out of sample forecast. Now I can drag down this formula. This concludes the basic demonstration and introduction of Holt winters. Again, it is important to understand the conceptual underpinnings and the ability and the capability of Holt winters in terms of capturing trend and seasonality. That's a unique feature of Holt winters. It makes it very powerful with practice, of course. And again, we have to practice a little bit the implementation of this method. Again, I understand that there are a few steps involved, but please try to do these and replicate what I just did. Again, if you have any questions, feel free to contact me. Thank you for watching.